So we'll solve for the next exercise, which is from chapter 3. In an experiment to determine the radar cross-section of a Tomahawk cruise missile, a 1000 watt at 300 megahertz signal was transmitted. So we know that the power transmitted is equal to 1000 watts at a frequency of 300 megahertz. Okay, so signal was transmitted towards the target, and the received power was measured to be 0.1425 milliwatts. So PR is equal to 0.1425 milliwatts. The same antenna, whose gain was 75 dimensionless, was used for both transmitting and receiving antenna. So we have an antenna, we have a Tomahawk missile. So we are sending a signal towards the missile, and we are having a signal coming back. So the same antenna is being used for transmitting and receiving, and the gain of this antenna is equal to 75 dimensionless. Okay, so the polarization of both signals are identical, meaning like the PLF factor, the polarization loss factor, is equal to 1, and the distance between the antenna and the missile was 500 meters. So this distance from here to here is equal to 500 meters. What is the radar cross section of the cruise missile? So what we need to find is the radar cross section. So we'll look at the equation in the book. That's equation must be equation 2.2-119 or 9120, and that's this equation: PR divided by PT is equal to radar cross section, gain of the transmitting antenna, gain of the receiving antenna, 4 pi wavelength, 4 pi R1 and R2, this all to the square. So we have our values. So we got the power received is equal to 0.1425 milliwatts. Power transmitted, which is 1000 watts, equal radar cross section, that's what we're looking for, and the gain of the antenna. So since the gain of the antenna they're equal, so we have 75 times 75 divided by 4 pi, and the wavelength of this antenna is equal to 3 times 10 to the 8 divided by 300 times 10 to the 6, which is equal to 1. So this is equal to 1, 4 pi, and the distance, which is the same for R1 and R2, is equal to 500 times 500. All these to the square value. If we solve for this, which is the radar cross section, we end up with a value of 31,420.29.